Hello, fellow introverts, and welcome back to the channel. Today, we're going to talk about a topic that's been getting a lot of press recently. It's everywhere. You can't really go anywhere on any sort of media without running across something about artificial intelligence. So, I thought it'd be nice to kind of get down, break it down and see what actually artificial intelligence is and if it's good or bad for us. So, buckle up, and here we go. Now, artificial intelligence refers to the development of computer systems that can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision-making, and language translation. AI systems are designed to learn from data and improve their performance over time through machine learning algorithms, neural networks, and other techniques. AI can be categorized into several types based on its function, such as rule-based artificial intelligence, also known as expert systems or knowledge-based systems. It's an approach to artificial intelligence that uses a set of predefined rules and logical reasoning to make decisions and solve problems. These rules are typically created by human experts in a particular field and are represented in a formal language that can be understood and processed by a computer system. In rule-based AI, the system follows a set of rules to arrive at a conclusion or make a decision. The rules are usually that of a if-then format. So, if this, then that. Where if a certain condition is met, then a specific action is taken. For example, a rule-based system in the medical field might use a set of rules to diagnose a patient based on their symptoms. The main advantage of rule-based AI is its transparency and explainability. Since the rules are explicitly defined, it is easy to understand how the system arrived at a particular decision. Rule-based AI is also relatively easy to develop and maintain compared to other AI approaches. However, rule-based AI has limitations, as it relies heavily on the accuracy of the rules defined by human experts. If the rules are incomplete or inaccurate, the system may not be able to make the correct decision. Additionally, rule-based systems may struggle with uncertainty and may not be able to handle complex or novel situations where rules do not exist. Secondly, machine learning. Machine learning is a subfield of artificial intelligence that enables systems to learn and improve from experiences without being explicitly programmed. ML algorithms use statistical techniques to analyze and learn patterns from large amounts of data, then use this knowledge to make predictions and decisions on new data. There are three main types of machine learning. Supervised learning. The machine learning algorithm is trained to use labeled data, where the input data and the output labels are provided together. The goal is for the algorithm to learn to predict the output labels for the new input data. Unsupervised learning. The machine learning algorithm is trained to be unlabeled data, and the goal is to find patterns and relationships in the data without predefined labels or categories. Reinforcement learning. The machine learning algorithm learns by interacting with an environment, where it receives feedback in the form of rewards or penalties for its actions. Machine learning algorithms can be used for a wide range of tasks, such as image recognition, natural language processing, recommendation systems, and predictive analytics. The more data the algorithm has to learn from, the more accurate it can become. Machine learning algorithms are continuously learning and improving, which makes them useful for tasks where there's a lot of data to analyze and where the rules are constantly changing. Thirdly, deep learning AI. Deep learning is a subfield of machine learning that involves the use of artificial neural networks to learn from a vast amount of data. Deep learning algorithms use multiple layers of interconnected nodes, also called neurons, to learn increasingly complex features of the data, allowing the system to perform more advanced tasks such as images and speech recognition. Deep learning algorithms use a technique called backpropagation to adjust the weights of the neurons to minimize the errors between the predicted output and the actual output. This process is repeated over and over again, with the algorithm adjusting the weights of each iteration to improve its accuracy. Deep learning algorithms are particularly useful for tasks such as image and speech recognition, natural language processing, and autonomous driving, where large amounts of data are available and complex patterns need to be identified. Deep learning has produced remarkable results in these areas, with systems that have recognized objects and images with superhuman accuracy, transcribe speech with high accuracy, or even generate realistic images and videos. However, deep learning algorithms require vast amounts of data and computational resources to train, making them more complex and resource intensive than other machine learning algorithms. Additionally, the lack of transparency in the decision-making process of the deep learning algorithms can make it difficult to interpret their results and explain their reasoning. Lastly, natural language processing, or NPL, is a subfield of artificial intelligence that focuses on enabling machines to understand, interpret, and generate human language. NPL algorithms use various techniques such as statistical models, machine learning, and deep learning to analyze text and speech data and extract meanings from it. NPL has numerous applications in various fields, including language translation, sentiment analysis, chatbots, speech recognition. For example, NPL algorithms can be used to translate text from one language to another, analyze customer feedback to determine their sentiment towards a product or service, and enable controversial agents such as chatbots to understand and respond to natural language queries. NPL algorithms can also be used for more complex tasks such as natural language understanding, where the system can understand the meaning of the text and extract relative information. This can be used in fields such as healthcare, where NPL can be used to extract relevant information of medical records and assist in diagnoses and treatments. NPL is a challenging field as human language is complex and vast, and the meaning of words can depend on the context in which they are used. Additionally, language can be ambiguous and people can express the same idea in multiple ways. However, advances in NPL have made it possible to build sophisticated systems that can understand and generate natural language with a high degree of accuracy. Now, you might be wondering how all this technological wizardry happens. So, this is how AI is developed through a multi-step process which involves the following stages. First, problem identification. The first step in developing AI is to identify the problem that the AI system needs to solve. This could be anything from automating a task to making predictions or recommendations. 2. Data collection. Once the problem is identified, the next step is to collect relevant data that will be used to train the AI system. This could be structured data such as numbers and categories, or unstructured data such as text and images. 3. Data processing. Before the data can be used to train the AI system, it needs to be cleaned, transformed, and organized into a format that the AI algorithm can work with. 4. Algorithm selection. The next step in the selection is the appropriate AI algorithm that will be used to analyze the data and make predictions or decisions. 5. Model training. The AI algorithm is trained using the pre-processed data, and the weights and parameters of the model are adjusted to minimize the error between the predicted output and the actual output. 6. Model evaluation. Once the model is trained, it is evaluated on a test set of data to assess its performance and accuracy. 7. Model development. Once the model has been evaluated and deemed to be accurate, it can be deployed into a production environment to make predictions or decisions. 8, and the final step in the process, model monitoring and maintenance. After deployment, the model needs to be monitored to ensure it continues to perform accurately. Maintenance may also be required to update the model as new data becomes available or it is improved its accuracy over time. The process is iterative and improvements can be made at each stage to enhance the accuracy and performance of all AI systems. Now you may be asking yourself, what could we possibly need this for? So there are a few fields which AI is taking to the forefront, the first being healthcare, where AI is used to analyze medical data, assisting in diagnosis and predict outcomes, which can improve patient care and outcomes. 2 is finance. AI can be used to analyze financial data, detect fraud, and make predictions about stock prices and other financial markets. Retail, AI can be used to personalize product recommendations, inventory management, and supply chain optimization. Manufacturing, AI can be used to optimize production processes, reduce defects, and improve quality control. Transportation, AI can be used for autonomous vehicles, traffic management, and logistical optimization. Education, AI can be used to personalize learning experiences, assess student performance, and provide personal feedback. 7. Natural language processing. AI can be used for speech recognition, language transition, and sentiment analysis. 8. Cybersecurity. AI can be used to detect and prevent cyber attacks, identify network vulnerabilities, and analyze security threats. And 9. Probably the most important, entertainment. AI can be used to personalize content recommendations, analyze user behavior, generate realistic graphics and animations. These are just a few examples of the many applications of AI. As the technology continues to advance, new and innovative cases will emerge, enabling us to tackle some of the most complex and challenging challenges facing our society. Now, here's the big question. Do we need this? Should we be wary of the development of artificial intelligence? Now, I choose to stay neutral, so I'm just going to present facts. But, as with any technology, people should be aware of both the benefits and potential risks associated with artificial intelligence. While AI has the potential to revolutionize many aspects of our lives, it is important to recognize that there are also potential risks and drawbacks that need to be addressed. Some of the potential risks associated with artificial intelligence include bias and discrimination. Artificial intelligence algorithms can perpetuate existing bias and discrimination as they are trained on historical data that may continue biases. Job displacement. Artificial intelligence has the potential to automate many jobs, which could lead to job displacement and economic inequality. Privacy and security. AI systems often require access to large amounts of data, which could be used to invade privacy and compromise security. Safety. Autonomous AI systems, such as self-driving cars, could pose a risk if they malfunction or are hacked. And 5 is control. Artificial intelligence systems are designed to make decisions autonomously, could raise concerns about who is responsible for the decisions that they make. Therefore, it is in fact important to develop ethical guidelines and regulations to ensure that AI is developed and used in a responsible and ethical manner. These include designing AI systems to be transparent, accountable, and respect privacy and human rights. Now, we can only get the government to do that. In summary, while AI has the potential to bring benefits to society, people should also be aware of the potential risks associated with it and work to address the risks through the responsible development and regulations. In summary, AI has the potential to be more beneficial than not, but it is important to approach its development and use with caution, awareness of potential risk, and the focus on responsible and ethical implementation. Which again, I do believe that we're getting towards the end of science where Yes, we can, but should we? And with that, I'm going to leave you nerds, and thanks for hanging out with me and talking about robots. So I'll talk to you nerds later.